Deep in the constellation of Cygnus, nearly 4,000 light-years from Earth, there exists a world that has literally walked through fire and survived. This is Kepler-70b, a scorched, rocky remnant that orbits its host star at such a terrifying proximity that its surface temperature exceeds that of our own Sunday. It is a planet that should not exist. Millions of years ago, its host star swelled into a monstrous red giant, swallowing its inner planets whole. Yet, instead of being instantly vaporized in this stellar furnace, Kepler-70b endured, diving deep into the boiling plasma of its parent star and emerging on the other side as a stripped, glowing obsidian core. It remains one of the most extreme survivors in the known universe. This extraordinary world was discovered in 2011 by NASA's Kepler Space Telescope, an instrument designed to look for the tiny dips in starlight caused by passing planets. However, Kepler-70b was not found using this standard transit method. Instead, astronomers noticed subtle variations in the brightness of the host star, Kepler-70, caused by the planet reflecting the star's intense light as it orbited. The host star itself is a bizarre cosmic remnant, a hot subdwarf B star. This is the exposed helium core of a star that has already lost its outer envelope of hydrogen. Located approximately 3,850 light-years away, this dying star burns at a blistering 27,000 Kelvin, casting a harsh, ultraviolet glare across its immediate neighborhood. Orbiting this stellar ember is Kepler-70b, a planet roughly 3/4 the size of Earth, moving through space at a speed that defies imagination. To understand the physics of Kepler-70b, one must look at the extreme dynamics of its orbit. The planet is locked in a tight gravity grip, completing a full orbit around its star in just 5 hours and 45 minutes. Because it is so close, a mere 900,000 kilometers from the star's surface, the gravitational tidal forces are immense, locking the planet in a permanent embrace where one side always faces the blazing stellar furnace. On this permanent day side, the temperature reaches a staggering 7,300 Kelvin. If you stood on this molten surface, everything you have ever known, from the steel of our tallest buildings to the toughest diamonds, would instantly melt, boil, and dissipate into a metallic vapor. Your body would not just burn, it would dissolve into its constituent atoms in a fraction of a millisecond. This extreme heat is actually hotter than the visible surface of our Sun, which burns at a relatively cool 5,800 Kelvin. Kepler-70b was once a gas giant, a massive world similar to Jupiter, wrapped in a thick, protective blanket of hydrogen and helium. When the host star expanded during its red giant phase, it grew to over 100 times its original size, engulfing Kepler-70b. For millions of years, the planet plowed through the dense, hot stellar envelope. The friction of the star's outer layers acted as a giant brake, spiraling the planet inward while simultaneously stripping away its thick atmosphere. The intense heat boiled away the outer gas layers, exposing the planet's heavy, metallic rocky core. What we see today is the naked, scorched skeletal remains of a once giant world. The speeds involved are truly astronomical, with the planet tearing through the stellar plasma at hundreds of kilometers per second. The planet's density must be incredibly high to withstand the intense tidal forces that threaten to tear it apart. At less than 1 million kilometers from the star, the gravitational pull on the side facing the star is vastly stronger than on the far side, creating a stretching force that would rip a normal planet like Earth to shreds. Kepler-70b must be composed primarily of dense iron and nickel, packed so tightly that its internal structure can resist this relentless cosmic tug-of-war. If a human spacecraft could somehow approach this world, it would detect a landscape of liquid iron oceans, constantly whipped by intense solar winds that sweep away any temporary rock vapor that evaporates from the day side. Despite these concrete measurements, Kepler-70b presents a profound mystery to astrophysicists. Standard models of stellar evolution suggest that any planet engulfed by a red giant should be torn apart by tidal forces or completely vaporized by the extreme heat within a few thousand years. How did this planet survive the deep dive into its star's interior? Some scientists hypothesize that Kepler-70b must have possessed an exceptionally dense, iron-rich core that could withstand the crushing pressures and searing temperatures of the stellar envelope. Another intriguing mystery lies in its relationship with its sibling planet, Kepler-70c, which orbits just slightly further out. These two worlds orbit so closely to each other that they occasionally experience gravitational interactions that alter their paths, making them the closest pair of planets ever observed in terms of orbital distance. If both survived the engulfment, it suggests that the process of common envelope evolution is far more survivable than previously assumed, or that these planets did not survive the red giant phase at all, but rather formed after the star shed its outer envelope, condensing from the leftover metallic debris. The survival of Kepler-70b is more than just an exotic astrophysical curiosity, it is a dark preview of our own cosmic future. In approximately 5 billion years, our Sun will exhaust its hydrogen fuel and swell into a red giant, expanding outward until it swallows Mercury, Venus, and almost certainly the Earth. For decades, astronomers believed this engulfment would mark the absolute end of our world, leaving nothing but dust. Kepler-70b proves that a rocky core can endure the stellar fire. When our Sun eventually dies and shrinks into a white dwarf, a scarred, metallic remnant of Earth may still remain, orbiting in the cold dark, a silent testament to a world that once was.